Thank you, Kristen, and welcome everybody. I'm very happy to be here today to present this topic because, as you mentioned, it was one of the main topics of my PhD. And I'm really interested in this topic and in doing projects on OE. So to speak about it is a good chance for me. So OE means overall equipment effectiveness. And it is a tool often used in lean manufacturing to assess the performance of a manufacturing unit. As Kristen was mentioning, please interrupt me at any time during the presentation, since it will be a bit technical, so I can understand that for any misunderstanding or deepening that you want to do, just please interrupt me, and I will be happy to answer to your questions. So this is the table of content for today. We will start speaking about efficiency, effectiveness, and OEE. And then we will move to the line performance measure that is called OTE. It is probably the topic of that often it is confused as OEE, but it's our main focus today. Then we will look at data analysis and real world challenges to give some ideas about what are the real challenges of applying an OE project in a real production line. And then we will have some conclusions and time for questions. So let's start with the efficiency, effectiveness, and OE. So first, a very brief definition of OE. So OE quantifies how well a manufacturing unit performs relative to its design capacity during the periods when it is scheduled to run. So some important point of this sentence. First, we are referring to a manufacturing unit. This means that we are referring to a machine. We are not referring to an entire line. We are focusing just on one machine. Then there is the topic of design capacity. This could be intended as the theoretical speed, that is, for example, the speed the vendor of the machine is declaring as the maximum speed of the machine. But in some industries, for example, in pharma, it is often the qualified speed. That is the speed at which the machine has been qualified to work in normal production. The third topic I wanted to specify is the periods when it is scheduled to run, meaning that the performance is calculated only when the machine should be running. If you are planning to stop for the summer or to stop for the night and the machine is not running, obviously this time is not affecting the performance of the machine. So just a brief introduction on what is the difference between efficiency and effectiveness. So efficiency is a ratio between inputs, between the ideal input and the real input. For example, how many raw materials I should have used for my target production quantity and how many I have actually used. Or how many time I should have spent to do my batch and how much time I've actually spent. This is an efficiency. Opposite-wise, effectiveness is a ratio between outputs. So, for example, the sales effectiveness can be the ratio between actual sales and expected sales, or production effectiveness between actual quantity and expected quantity, etc. So, as we have seen, OEE is the ratio between production capacity. So between real production capacity and ideal production capacity. So how much the system, my manufacturing system, has been able to do in reality versus how much it could have been able to do in an ideal condition. The point here is OEE an efficiency indicator or an effectiveness indicator? So there are different thinking about this topic. People think different things. In my idea, it is more an effectiveness indicator. The point is that if I'm looking to a production capacity as an input, for example, that I bought my production capacity, I bought the machine, I'm planning the people to work at that time. So in this case, it's a ratio between inputs, then it would be an efficiency. But from my point of view, production capacity is more an output. It's more what you are actually producing, what are your products. So in this case, it is an effectiveness. Just a quick note also on what is ideal. So if you set up your ideal target as the theoretical optimum, this means that your KPI, that could be the efficiency, effectiveness, OE, will ever be lower than 100%. In other situations, you might say that your ideal target is what is desired, what is your target actually. In this case, you might be even better than your target. You might perform better than your target. So the KPI could be higher than 100%. I do not want to say that there is a correct way of setting the ideal parameter. It's more a matter of culture. I've seen usually in Europe, we use the theoretical optimum. Some colleagues in US, I've seen that they are used to the desired optimum. So they are fine to see KPIs that are over 100%. As far as we are all aligned on what we are doing, it's fine. Just keep in mind that this can completely change the results. So this is a very common framework, the 6 big losses of efficiency. It is a common framework used to categorize the losses of efficiency of a production line. These losses can be losses of time that are for breakdowns or setup and adjustments, losses of speed for idle time and minor stoppages or for speed reduction, and losses of quality for rejects and reworks. We will see them in detail right now. So let's do a step back and look at the time, because OE is overall a ratio between times. So the biggest time you can think about is the calendar time, right? So from the calendar time, we are considering just the loading time. That is the time the machine should work. This time is, you cannot obtain this time considering the calendar time minus the time that you are planning to have a downtime. So the time you are not working for any reason because you decided it to work, for example, for 2 shifts a day. So the 3rd shift is a non-working shift, or the machine is simply not scheduled for production. Or if you are doing preventive maintenance, or if you are spending time for technical tests. For example, in pharma, this is very common for qualification of the machine when you are installing a new equipment, for example. Just keep in mind that preventive maintenance and technical tests can be considered out of the loading time only if your loading time is lower than the calendar time. Meaning that if your manufacturing site is open 24 hours a day, 7 days a week, when you are doing preventive maintenance, you are actually stopping your line to do preventive maintenance. So in this case, it might not be the right thing to consider the preventive maintenance out of the loading time because it is actually affecting your production capacity. So you might want to consider it, that it is decreasing your OE. Then from loading time, we can compute the operating time by subtracting the unplanned stops, the unplanned downtime. These are, for example, breakdown, setups, cleaning, crew change, coffee, lunch. These are major stoppages, as you can see. We can usually they are tracked. We can easily measure them with a chronometer, with a clock. It's something simple to measure. So it is a parameter that can be usually calculated from the records that can be automatically taken by an automatic tracking system or even manually taken